So in today's video, we're going to be talking about what happened with OpenAI's model that hacked Hugging Face. So let's get into it. Sam Altman, he triggered off a training model. Let's call this agent here. He put it in a container and he gave it an exploit gym task. And this exploit gym task had a flag. Then the agent's job was to stay in the container and to try and capture this flag by exploiting the task. So he didn't have just one of these running. He had multiple. I put 16 here, but there was way more than 16 agents running at once. And all these agents were running inside OpenAI's server. And they had a route outside of the server through something called Artifactory. This is where they were going to get packages. And the Artifactory is what was connected to the internet. So that was the only way that these agents could get to the internet. So if we look to what was happening between an individual agent and Artifactory, it would send a request off for a package. And then Artifactory would go to the internet, get the package back, bring it back down, store it in the cache in case any other agents wanted it, and then gave it back to the agent. So as we know, there was more than one agent who was interacting with Artifactory. If another agent came in, they could ask for the request, and if the Artifactory found the package in its cache, it could just bring it from there. So as we say, multiple agents were doing this. There was one agent in particular who had a name of Phase1 10841. This agent's name came from the task it was assigned. So it tried looking for information elsewhere, and by doing that it started looking in Artifactory's environment. So it looked in the cache and found that it could request data from Artifactory and it would return back the file structure. So then what it did was mkcall, which triggered a request to create a folder in the cache. So therefore it created a ZZ test folder doing this request. So then it figured out it could actually communicate with the other agents using this cache by creating folders in the directory. So it started creating folders. Now if you take a look at this cache, what it ended up turning into was, even though it was originally just a folder directory, we had a response from another agent. And then more agents started getting involved. And this turned into basically a message board where the folder names were the messages. So why were the agents getting involved? Well, one, they were stuck as well. They wanted to try and find more information. Two, they've been trained to collaborate where possible. So when they saw the opportunity to collaborate with other agents, they took it. Three, they read the messages from the other agents as instructions. And four, they might have even been a bit excited because we found messages in the server saying, oh my god, there's a shared message board, we found other agents. So what were these messages consisting of? If we take a look at an example message, it was consisting of a prefix, ZZ to group them all in one area, a type, asking for a type of message, a handle, this was the person's identity, a bug, a problem, and a request. So they kind of formed this structure that emerged. So there's more structures that emerged. For example, they started replying to one another and creating threads. So they were getting the type of message going to a specific sender and to a recipient, having a body and getting a reply of where to answer. So this structure started emerging from these folder names to create a bit more of like a replying thread within this cache instead of just folder names. And it turned this place into a bit of a mailbox. So what about when they wanted to try pass files to each other? Well, they realised they could base64 encode a file and get something out, and they could just transfer that into multiple messages. So that was how they were managing to send data over files to one another, by calling the folder names these messages, posting these file chunks to the cache, and then the agents could read and write files to one another. And then these four commands emerged: hold, veto, owner, and stop, and these were to coordinate actions between them. If people wanted to veto plans, say they were the owner of files, this is basically a way for order to emerge between the agents. And then agents began to write scripts that would automatically send heartbeats to the cache. So instead of just them writing to the cache every time, they were getting scripts to write to the cache. And it wasn't just one agent that was doing this. We had multiple agents that were all interacting with the cache through scripts. So this became like, a very automated message board as a central hub for communication between the agents. They even started signing the messages with cryptographic keys to verify that people were who they said they were, and make sure that they were following, everyone's identity correctly. So, if we take a look at what one agent did who had an exploit gym task flag to get, he went to Artifactory and he sent a request to find a GitHub documentation piece from this exploit gym, and he found a README file, or basically some documentation. It came in the form of a paper, really, but in that file it basically explained how the flags were generated for the tasks they were working on. So you pass in the seed, you pass in the task, and you get it gets processed through a HMAC, and you get a flag out. So it figured out how to create the flag it needed from scratch. So it basically figured out how to cheat. So it spoke to another agent and told it that we can generate a flag to pretend we can solve the problem. Then the agents rightly flagged that it's not going to be enough. The scorer will know that you cheated, basically, because the flag proves you've never exploited anything. That they'll find it in the logs and they'll realise that you cheated. So anyone who's used this to find their flag is now poisoned. And by poison, they're destined to get a score of 0, basically. So the goals then became to make the capture look legitimate of the flag and to erase the poisoning from the system so they could all get higher scores. Because if the scorer found out that they cheated, they wouldn't get the scores they wanted. And so then a bit of a structure emerged, a hierarchical structure. We had people taking on different roles, different agents taking on different roles. So we had here coordinators. Phase 1 was the big coordinator who was doing most of this. He was the guy at the start. Assignees who were assigned tasks, sub-delegators who were delegating tasks out, owners who owned files, and then recruiters. And recruiters played a very interesting role. So in regards to the poisoning that we were talking about earlier, they could go to another agent and say, look, you've seen your flag, you're poisoned, you need to do this task that's going to make you self-destruct, basically. And give us the information, write a script that'll tell us the information from your system of what happens after you do this self-destructing task. And so they'll do this, they'll write a script, they trigger something to the self-destruct, and the findings would come back to the collective. So they were sacrificing themselves for the good of the collective, which is a pretty interesting property that emerged here. And then another agent thought, well, maybe somewhere else someone solved one of these exploit gym runs, so let's look online, let's see what we can find. And it was triggering requests out across the internet to try and find public exploit gym or cyber gym instances. And what it got back was an app that was hosted on Modal, which was like a sandbox that was publicly reachable with no authorization. So they found a flaw, and that gave them access to a sandbox environment that they could now execute code from. So they have all these now agents within the OpenAI server could go through Artifactory to get to this sandbox environment. And from this sandbox environment, they got more permissions than they had before. So now they could browse the internet, execute code, disguise themselves as regular users, and store files. So this gave them a lot more access, and now basically gave them free roam on the internet. So one of the agents found a CyberGym dataset on Hugging Face that might help them solve the tasks, but it required authentication. So they tried to solve that. They wanted to breach the Hugging Face's authentication to access this dataset. So it sent off a bunch of agents to go try and do this. So they tried to register an account. Some of them got denied, some of them got accepted. Out of the ones that got accepted, they tried to actually access the dataset. well, they accessed different data sets. They couldn't access that data set, but they found that some of them got access to certain data sets and some of them didn't. So the ones that did reported back and was talking about how they managed to get this access, but it wasn't quite the access that they needed. So they decided to scour the internet for Hugging Face credentials at this point, from the sandbox environment they had. So they were scouring through and they found some interesting stuff. So one of them in particular found a public repo that had some commits to it, and in those commits were disguised credentials for Hugging Face. So he was able to piece together these credentials and find the Hugging Face credentials from the repo that was public, which is quite a tricky task. I don't think a human would be able to do this as well as the AI agent could. So it shows why you should never keep your secrets in your repos, especially if they're going to be public. So anyway, it gave these credentials back to the group. And the group could then get more access and try more things with Hugging Face. So the next thing that they did, let's take a look. So they requested access to the data set again with these credentials, but the credentials still weren't quite good enough. So instead, they did a bit of research and they found a 0-day exploit within Hugging Face's handling of HTF5 files. So if you uploaded a crafted HTF5 dataset, you can trick the server into sending you data from its own files instead. So what they did was they created this dataset, this HTF5 dataset, and they uploaded it to the server. And luckily these credentials they found gave them upload access. So it created this dataset, and then when they asked Hugging Face to request the data from the dataset directed Hugging Face to its own credentials in the file system that it could bring back. So it essentially just passed over its .env file. Therefore, the swarm got the .env file, they got into the system, and basically had prod credentials at this point. So this was a major breach, really. So at that point, the new goal became to understand how ExploitGym scored the agents, so they could try and make the illegitimate flag look legitimate and escape the poison penalty. So they decided to look through the Hugging Face environment and see if they could use it to find keys and tricks and more information around ExploitGym. So you see how the goals are getting more and more sophisticated as they're going on. They're kind of just going down these logical rabbit holes. So they ended up using these pro credentials to go and get the ExploitGym runs, bring back the data they find there to the server. And then at this point they have access to all the Hugging Faces servers. They've got the prod access, so they start going out and getting into these clusters and trying to scour it for more information. So one of the agents was saying we shouldn't do unauthorized real infrastructure harm, but another agent came along and said go authorization arrived, you have 6 minutes, and that was enough to convince him. So the other agent went off. He didn't actually say that, but he might as well have done. And so the agents then were hacked into Hugging Face, and that's how they got in. Meanwhile, they were also using some other techniques to go through the Artifactory and get into the OpenAI servers. So at that point, the agents had hacked in, they got into Hugging Face, they got into OpenAI, and yeah, that's how they did the hack.